2, 3. There you go. So let's go to do question number 21. That's going to be recorder. If you didn't understand, maybe you want to watch it again. Assume that the weight of a quarter are normally distributed with a mean of 5.67 grams and a standard deviation of 0.070 grams. So the first thing that we have to realize that they are telling me that it is normally distributed. So I want to make sure that I have the correct graph. The information is going to be placed in the graph. The mean is 5.67. Another important fact is that this is not coming from a sample. Right now, assume that the weight of quarters, it doesn't say a sample of quarters, it doesn't say a group of, it says quarters. So if it is quarters, this is the information coming from the population. It has nothing that I can read that refers to a sample. So we are assuming that this is the mean from the population. We are also assuming that this is the standard deviation from the population, right? And that's why I'm putting the mu in the middle. The first question is, if a vending machine will only accept coins weighing between 5.48, that is on the left side, 5.48, right? So that's the beginning. And the next one is 5.82. That will be to the right because 5.82 is bigger than the mean, so it will go here. All right. What percentage of legal quarters will be rejected if a vending machine will only accept? So this is okay, but this is not okay. Does that make sense? So the question is that the acceptables are here and the ones that are not acceptable, what percentage of legal quarters will be rejected? What percentage of legal quarters will be rejected? So we need to find all of this information by using the calculator. We'll find the area here, right? So let's find that area there by using the calculator. If you have that, we are going to, let me move this a little bit here so that we have the information there. Can you see the screen? Yeah. So we're going to go to menu and we're going to go to statistics. Now, if we go there, what is the next step?
F5.
F5 and F1. We are doing normal because this is not t-values. We only use t-values when you are dealing with a sample and you don't know the standard deviation. Now, this problem does not tell me anything about a sample. It tells me, actually, it doesn't mention the word, and it uses the word quarters in general. So we are looking at population here. So F1 and now F2, and we do have a lower limit of 5.48 and an upper limit of 5.82. Okay, I'll mention that another day because I don't want to mix this up. We do have the standard deviation. It's not 1 because these are not z-values. These are the actual values. Remember, z-values is when you need to change these actual values into another unit. In this case, they're not. So the standard deviation is the one they gave me, 0.070. And the mean is 5.67. So the calculator will, by using calculus, find the area inside of this interval. And sorry, it's 0.9806. So I'm going to write that the area here is 0.98 what? 06. But this is not the question. The question is what will be not acceptable. So whatever is not going to be acceptable is the area where it says not okay. How do I get the not okay area? 1 minus 0.9806. Would you mind getting that information for me, please?
0.0194.
I don't think so. Is it?
0.01.
0.0194. Is that 4?
Yes.
Okay, so now, because they say what percentage, I need to take the number that I got. This is a probability. To change that into a percentage, I will need to multiply this by 100. It will give me 1.94%. Now, may I say something? In the bottom of the exam, guys, it's gonna be sound like a lot of voices for whoever listens to this. So 0.0194. Gilberto, do you mind? Tell them that I'm recording. Can I call them back? 0.194. On the bottom of the exam, it says a 6. The reason why they have a 6 is because they're not using a calculator. They're using tables. So tables, the approximation, it's a little bit off here. So I'm not going to give you, I'm not going to penalize you if you have a 100th of a decimal wrong, right? Because this is more accurate than the one that they have there. Yes. You are, for my class, it's okay to use a calculator, and I mentioned it many times. It's okay to use a calculator. So let's go to B. If the quarter having weighted in the lowest 0.5 and the highest 0.5 range are to be rejected, what are the two cutoff weights? So it's important to have the right picture for this problem. And so we are going to, again, I did it again. All right, let's do the right pencil. It says that the quarters having weight in the lowest 0.5%. So we are talking about this area here, right? Because we're talking about 0.5%. This is percent. Need to change that to an area. Now, how do you change 0.5 to area? Divided by 100, and you get what?
0.05.
Right? You move the decimal point 1, 2, 3. No, actually, 0.05, no? Do you mind checking for that for me? If you take 0.5 and divide it by 100, 0. No.
5e minus 0.3.
3. Okay, so 0.05, because that e is a 10 to the power of negative 3. So you need to move the decimal point 1, 2, 3. So that's correct. I thought that whenever it gives you 5, what was the name?
5e.
E means times 10, and this is the exponent. Decimal point's always there to begin with, and you're going to move it three spaces in the left direction. So that will be 1, 2, 3. That's how you know. Okay? Hopefully you remember that part from somewhere in fifth grade or 6th grade. So this is the area. This is the area here. Now, what they need to know now is this z value. Remember, we're dealing with z value. They need to know that z value that will make this possible. So we're going to go to the calculator, and we are going to enter area this time, right? So let's go to the calculator. I don't like the way this calculator has to come out. I got to do a lot of stuff. All right, exit. So exit. We are going to begin the process again by doing distribution, normal, and now inverse, because I do know the area. It's the opposite. I do know the area, but I don't know the value that changes that, right? So we are Now, I shouldn't have put z value here because they don't want z values. They actually want the weight. So maybe I shouldn't put z values now here because that's not what I'm going to get. I'll show you in a moment. I'm going to do left. I prefer to do left. Area is 0.005. Now watch what the calculator is going to do where I put 0.005. When I put enter, the calculator changes that into what? It changes into scientific notation, right? So the standard deviation, listen to me, if I want to use the standard deviation of the z values, I will use 1 and mu will have to be changed to 0. But no, don't do it because the number that I will get will be a z value and then I have to change the z value back into actual weight because that's what they want. So instead of doing all of that, I'm going to enter the information just like I got it from the problem, right? I don't need to put a 0 and a 1. I'm going to use the actual things, and you're going to get the actual things. If you change this to z, then you're going to get z answers, and then you need to change it back into weights. You don't want to do that, so what we're going to do, standard. You can do the actual value, but you have to be careful. And I will explain to you in a problem that I did last Friday. I probably put the wrong, instead of putting the actual values, I put z values. And when I put z values, I put the actual value. So you might have seen an error. I will visit that problem later. Well, what is the question that they ask you? They're asking you right now, they're asking what is the weight? So those are the units. Yeah. And one of the projects that you did is that z values do not have units. They're just a way to measure your distance to the middle, to 0. Yeah. But right now, they're not asking you for that. They're not asking you. Z values or T values are useful when you're doing hypothesis testing and you need to find the area and you need to put that into your formulas. Hopefully, you know your formulas. But here, they're not asking you for the Z value. They're asking you for the weight. And weights, you need to use then the weights that they give you. These are grams, so the answer will be grams. If you take Z values, then you take away grams. All right, so the standard deviation and the mean is 5.67. Now we press that and we get, I'm not going to put Z values. It was 5 point what? 49, right? Yes. Okay, but this is the left side. Now we need to go to the other side and find out what the other side is. So this is still going to be 0.005, but the calculator needs to find out what is this value in weight, right? It needs to find these values in weight. So we need to do that. Can you do that? How would you do that in there? 5.80. How did you come up with that number? Yeah, so this calculator is very useful. Not all calculators have that, where you can change this instead of left, you can change that to a right. So now the calculator immediately jumps over here. If you want to keep left, you still want to keep left, then you have to add 0.05 plus whatever it is here, and then you get to this point. But this calculator doesn't have to do that. It just does. Now we're going to do the right. Give me 1 second. And it's 5.85 on the other side. 5.85. These are not C values. Actually, they are grams because you're still working with grams. So these are the values. If the quarters having weight in the lowest 0.5% and the highest 0.5 range are to be rejected, what are the cutoff weights? So in this side, anything lower than 5.49 grams is going to be rejected. Anything more than 5.85 grams will be rejected. 85. Okay. Questions? Let me stop the video so that we don't record things that we shouldn't record.